Right, so basically the title of the talk is Gerbil and Gambit, as they say, Racket and Chez. So the idea is that we have Gerbil scheme, which started, I'm going to talk a little bit about it more later. It started as a project on PLT, as a PLT language, and it became its own thing. And now we go to the point where basically Gerbil has re-implemented the PLT microsystem and module system on top of Gambit. And we get into a situation where it's analogous to what we have with Racket and Chez. So basically, what is Gerbil? So first of all, it's a new dialect. Okay, it's opinionated. So basically, it has my biases. So as I said, it provides Racket-like facilities for Gambit. Okay, and the difference from Racket, which basically it's an all-encompassing language that is focused a lot of on academic. This is focused on systems programming. This is the kind of programming that I do. Okay, I also love explorative programming and everything in Racket, but that's not the programming I do day to day. Okay, and the idea is that this is a compiled language. So yes, we have an interpreter. It's perfectly capable. We can mix interpreted and compiled code, but at the end of the day, we care about producing binaries. Okay, and that's like for bottom half of the system, Gambit scheme is inside, so there is no new implementation. I didn't implement any scheme, the core scheme from scratch, so we're using Gambit scheme. Okay, as I said, it started as an actual language on PLT, okay? And the reason why this happened, okay, it's that ultimately Racket, as nice as it is for exploring and writing correct code and arguing about it and everything, it's very frustrating for systems programming. Okay, let's start with the big elephant in the room. So performance is mediocre. Okay, it's not bad for when you're doing explorative programming. It's great for explorative programming. But if you want something that's going to be running on your server for a while, you want it to run a little faster. And you also want to have a safety escape hatches. So there are cases where you're willing to give up some safety in order to go faster because these are CPU dollars that are sitting in there. And also you want your system to give you responses as fast as possible and scale it as much as you like. Okay, the other big problem that I have with Racket personally is that, I don't know how well it has evolved since then, but the thread system is very heavyweight. Okay, a thread points to a lot of stuff. It's a huge object. Okay, it takes like microseconds to create. The context switch takes 10 microseconds. Okay, and you can't even observe it. Okay, so you don't know how many threads are running on your system. You can't go into your threads and see what they're doing. So if something gets stuck, you're on your own. Okay, and then the rest is that basically, as nice as it is, it's a huge system, right? We're talking about the Titanic code base, and all these libraries and everything. You can't really distribute this. Okay, what you want in the end of the day is to be able to make a binary and send the binary out. Okay, so let's go from Racket to Gambit, from PLT to Gambit. That's perfect antithesis, okay? Because Gambit has good performance for scheme. Okay, plenty of safety escape hatches, even the infamous declare not safe. We can basically make your car go start-stop car and a LiDAR type checking altogether. Okay, and it has excellent introspection and observability. So I'm going to demonstrate this a little bit, but basically what this means is that you can go into your system and see what your threads are doing, and you can even enter the threads and hijack the continuation, okay, and examine things from the point of view of the thread. Okay, and it can create nice and efficient binaries. Okay, it takes a little while to compile. I'm going to say something more about this later. But the problem is that the top half is missing. Okay, so that's the problem that Gambit has. So that's by design, I would argue, and I would say that Mark did the right choice to not implement the top half of the system. Okay, because it's a small focus system that says it's a core scheme, it's an excellent scheme, and we're going to keep it that way. We have minimal macro facilities, so basically you can do define macro, and you can use the portable PC index if you want, but that's about it. Module system, sorry, we don't have that. We're still in, library, just direct, scheme files, and there are very few libraries. So Gerbil and Gambit, what it does is it takes the PLT micromodule system, it's scheme in scheme, so basically it's a new implementation of the expander. Okay, it's a clean room implementation. I made some certain decisions. Basically, there are differences in the model when you're moving from a primarily interpreted language into a compiled language. So these differences are reflected in the different structure of the module system. Okay, and the idea is that we provide the top half of the system. So we have Gambit sitting as the core of the system. Okay, we have the expander. There is a compiler that does, apart from the expansion and compilation to Gambit, it also does optimizations that Gambit cannot perform, like, for example, inlining case lambda dispatch or inlining struct accessor operations. So these are things that are important because an inline struct accessor operation, especially if you plug on it, like declare not safe, can be something that is, just as fast as struct reference. Okay, And basically, I've also been building libraries so that we can do day-to-day systems programming, and this is hopefully going to expand. Okay, and to close the lightning section, the slide section of the talk, is I would like to point this analogous situation. Okay, especially now that Gambit, now that Racket is moving into Chez, we have two minimal core schemes down there, sitting there, and we have microsystems and module systems and libraries sitting on top. Okay, and I think this goes back to the future of scheme, because right now it's like that we have some implementations that are really good at a low-level system, okay, and they're limited to what they can do at the top half, and then we build bigger languages on top that offer facilities that are missing from the bottom. Okay, so basically Gerbil wants to do what Racket does, and it's going to be doing on Chez. It wants to do it for Gambit. Okay, so that's the very basics for the introduction. I'm going to do a little demo. So before we go into demo, questions? Feel free to interrupt and everything. Okay.
Why not Chez? Just to ask, why not Chez scheme?
Why not Chez scheme? Yeah. Okay, first of all, when I started on Gerbil, Chez scheme was closed source. Yeah. Okay, and second of all is that I really like Gambit. I like the minimality of Gambit and the facilities that it offers. And the fact that I'm going to come back to that is that you can observe the system, and it has some great features for systems programming. Okay.
What changes, if any, have you made? You were originally trying to do like a Racket type or PLT type thing. So in the process of doing your
right. So
what are the big changes?
Yeah, the big changes in the module system. The really big one, the first one, is that the module system is single instantiation as opposed to multiple instantiation. So in Racket, that's a big difference, okay? And the naming scheme also is that basically because we're compiling and we want to be able to refer to symbols externally, is that we're actually using namespaces from Gambit. So basically the symbols get a namespace from the module, which you can specify explicitly. So the top level defined symbols have deterministic names. So this is the really big change from PLT. That's like a radical difference that gives a different flavor and forces you to do certain things differently.
So this is like closure. Feels like.
Well, it's closer to the module system in terms of the naming on the top level. You could think of it not just closure, basically just like what the common Lisp does with ASDF. So this isn't the Lisp tradition. This is not something that they pulled it out of thin air.
But that has implications for macros too.
It has some implications for macros. So the only thing you need to be careful about is top level symbols on your module. So if you need to define a package for your module, and then the expander will generate the right symbols for you prefixed by your packets, but you have to be a little bit careful about that. Okay, and there are other smaller differences. For example, there are differences in the practical implementations. There are no syntax certifiers in the Gerbil macrosystem because I thought those were just at Chez. Basically there's a system they have that this allows you to decompose the output of a previous expansion step. So we have that. You can deconstruct expansion and you can do internal expansion on that. Basically, we have syntax can be wrapped or unwrapped. So that's another big difference in the way you write macros. So you don't have to write everything into a datum to syntax object. So we just have the object going there.
Do you have local expand?
Yeah, of course. Nested expansion, you can do that. Yeah, and the receive and syntax local value, which I like very much. That's one of my favorite features of PLD.
Is it the new expander or the old one?
It's a brand new expander. I wrote it from scratch.
With the scope sets or the older PLT expander?
No, the expander is being written from scratch. So basically,
what hygiene algorithm? Which hygiene algorithm?
Oh, I'm using mark on the mark. So I'm using the standard can do the big algorithm. So I didn't invent one for news. Okay, so I want to do a quick demo. I'm fighting with them. Right, so let's do a little bit of explorative systems programming. So should I increase my font? Is this readable?
Should I go a little bigger, please?
Yeah.
It's better for the recording.
Let's make it 180.
But I'm in the first row.
Is this better?
Can you make it like twice or 3 times?
Yeah, go way bigger if you can. As big as
Okay.
The recording will probably not catch it.
I'll make it 240. No, that's too big.
Better, actually better.
Okay, that's much better. All right, so let's go into our scheme mode. So one thing that probably got lost in translation because I forgot to mention is that, as I said, PLT started as a language, Gerbil started as a language on PLT, as a microlanguage. What it did was that it did actors. Okay, it was an actor system on PLT. So the actors are still there. There's part of the standard library. So I'm going to do a quick demo with using actors in there. So let's try to make it explorative. Let's say that we want to do the simplest distributed systems component, a key value store. Okay. So we start with that, and we define the protocol, okay? And this is one of the modules that I have. Here is the reference about the packets. This is what is going to prefix the top-level symbols of the module, okay? And in there, I define a key value store. I can expand this if you want to look what it actually does. I'm going to take one step. Oh, sorry, I need to. We actually need a datum to syntax object here. Oh yeah. Actually, it didn't expand because I forgot that I need to. So this does a whole bunch of things. It defines a bunch of structs for your messages. So this basically, the protocol becomes a bunch of structs for your messages, okay? And a set of macros that allows you to send messages and receive them, okay, with reaction rules. So don't think the details matter all that much, okay? So before we start doing anything, let's just load our module into the interpreter. Okay, so we imported it and we have our key store connect and our methods and everything else. So right now we can't do anything. We just define the protocol and a bunch of helper methods that are going to help us define the actual implementations. And in the next step, I'm going to define a generic actor that implements this protocol and says here, our protocol has 3 methods, get, put, remove, and I'm going to implement the scaffolding for building the actor. So the actor is a function, okay, that runs in a thread, okay? So actor and thread are very much intertwined in Gambit because we have the thread mailboxes. So by starting a thread, you're effectively creating an actor and you can send in messages in there. Okay, so this actor runs in a loop, and basically this is another Gerbil micro that basically does the reception, the reaction loop. Okay, so it receives the key store get, okay, and here is some details about the implementation. The most important part is that it calls this generic get that we gave it to construct our our actor class, okay, and returns the result with a bunch of more actors. Okay, so let's import that too. Oh yeah, sorry about that. I need to add to the load path my. So far we've been working on the interpreter, and let's look at an actual actor, okay? So what's the most trivial actor you can think about, a key value store? Let's put an in-memory hash table. So I'm going to do a disk backed right after that. Okay, so that's the implementation of an actor, okay? And as you can see, it's a thunk that calls the generic function I defined by passing it internal functions there, okay? Okay, cool. So I'm going to run the hstore actor first on its own, okay? Hstore actor. Let's try to debug a little bit. Okay, now we can. I'm sorry, I'm having a few problems with my trackpad because it's a new laptop. So we have our guy running in here, and we can try to see if it has anything. It has absolutely nothing. Let's try. Okay, that's empty, and we can put a value. And then we can retrieve it. So far what we've been doing is that we've been testing a little actor on the interpreter, and let's do a more interesting implementation of an actor, and this one is going to use LevelDB. So you guys are familiar with LevelDB, I believe. It's one of the well-known key value stores. And there is, basically what it does, it converts the object to JSON, okay, and stores the object in JSON form. Okay, there's little difference in that. Okay, and so far we have managed to define a bunch of things, okay, and we played a little bit in the interpreter, so again. again, we can play with a reactor, okay, and we can put a value into a reactor and see what it is, okay? So what's interesting is that this value is going to persist, later on when we move and we actually try to use a compile, but here comes the interesting part. So right now we can see that we have 3 threads running in our system, okay?
Middle.
So we have the primordial thread, here is the 8-star actor, okay? This is what we implemented, and this is the level DB actor, the 2 actors that I spawned. Okay, and if we want, we can visit one of them. And we can see where it is, okay? And we can see the definition, so plenty of... And we can interact with the actor running directly, okay? So far we've been doing some explorative programming and everything is fine, but then it's time to build a binary, okay? Let's write a generic binary that basically says, okay, I can run both types of servers, okay? So here is the implementation. It's actually, this is the run. You give it a start server function, it's going to start the server, the address and the arguments, and it started. And the rest is a little bit of get opt scaffolding to get the commands, okay? So there is a build script here to, no, that's not what I wanted. And that's what the build script looks like. Okay, and I'm gonna run a kbstore d right now, which is just compiled, and I'm gonna use level db, and I'm gonna give it the path that I used into the other server. Okay, first of all, let me go and I'm gonna kill the other actor to basically relinquish the level DB, because there can be only one process that is open. That's one of the limitations of level DB. Okay, and I'm gonna run it here, and I'm gonna do something that it's gonna look a little magical here. So I'm gonna pass it a parameter that says, okay, run it here, and this little /dr thing that I put in here, that's a little bit of magic that allows me to basically Control-C into the running binary, okay, get the running server, the running threads, and it allows me to run code and basically inspect and poke my threads directly. That's one of the features that are basically is provided thanks to Mark Philly, who's done a great job on implementing all this stuff. And it's totally missing from Racket. So this is not something you can do on Racket. So what we can do is that, let's say that we want to talk to our thread directly, kbstore get, and we want to ask our thread, I need to find which one it is, it's thread 10. Then I'm going to ask it for a key. But before I do that, I'm going to go into a nested REPL to avoid accidents with the exception. I can explain this. Oh, yes, that's why. Oh, yeah. Let me do a little bit of more poking, because it seems that I'm going to do something even more interesting, because the binary is compiled, it doesn't have the expander. So it has raw eval, raw schema eval in there, but doesn't contain the Gerbil expander. But that doesn't mean that we can't load the expander inside the running binary, okay, which I just did. Okay, and now we can do an import in the running binary, and we can say demo. Here, let's get the guy, and we can do a kbstore. And we see that it has the value that was saved in the interpreter. Okay, and of course we can go back into the interpreter, and we can just interact with our running binary. So so far that's one of the basic parts that I wanted to show. So basically the idea is we start with explorative programming. We do Racket style programming with loading our modules and playing in the interpreter. And we can start compiling, earlier on. We can start building our modules, and we can do it in the interpreter. And eventually the end goal is to produce a binary, and that binary comes with an embedded REPL, okay? And that means you can do things like load the expander inside the binary, and you can poke it, and you can do whatever you like with that. So one thing that is missing is the ability to put breakpoints into compiled code. That we don't have yet. Okay, I'm talking to Mark about it. Maybe we'll find a way to implement it because there are some implications about implementing that.
How big is the binary?
So this binary that I compiled, that's actually a very good question because I have a second compilation. So that's a dynamic. Let me exit. Let's go on. So what we have, the binary is a dynamic binary, which means that all the modules that we compiled are loaded in the runtime. So it's a little bit like using shared libraries. Okay, so the module sim is tiny. It's like just 34 kilobytes. But this means that you need to have a working installation of Gerbil to use this binary. So what you can do is you can compile a static binary, okay, that has 0 dependencies on the Gerbil runtime. Okay, and I have this is going to take a little while. Let's see what the timing is.
We're about out of time, so.
Okay, that's about it. So the idea is that you can build a static binary that has no dependence to the Gerbil runtime, and you can disable this to your servers. So that's where we are. Okay?
Thank you.